All right, crew. So, I know it's hard to see me here. I'm trying to make sure you can see what I'm doing. But so next up, we're going to talk about electromagnets. So, for electromagnets, what you got to understand is that electricity and magnetism are related. That's why we've already talked about those two things kind of interchangeably here. So, with electricity and magnetism, remember that magnets can affect electrons, and the whole idea here is that not only can magnets affect electrons, electrons can affect magnets. That's where the term electromagnet comes from. They influence each other. Remember, magnets are merely the interaction between the spin of electrons, right, and a piece of iron or nickel. Yes, Maverick, I see. Please stop. Okay, so anyways, so we have demagnetized iron, we have magnetized iron, and then we have no magnetic material. Focus. Chill. So anyways, this is going to be very important that you understand this. This is demagnetized iron, this is magnetized iron. So what we're going to do is this. If you can take a look here, you'll see I have a little washer. Okay, in fact, I'll probably do it with this instead. It'll be a little easier. A paper clip, okay? And if you bring this paper clip here and you bring it close to this, you'll see the paper clip is not magnetic, okay? It's not magnetized at all. You have over here an iron nail. Do you see that right there? An iron nail's been hammered into here. Well, this iron nail, you can see you're touching it here, okay, to this, and nothing's getting picked up. Nothing's happening whatsoever. So let's leave that right there. So what I'm going to try is this. I'm going to take some electricity, okay, and what I'm going to do is I'm going to run it through this. This is called an electromagnet, and electromagnets are pretty straightforward constructions. You take a circuit of wire, so you can see you got the wire here, right? And you wrap the wire multiple times around your piece of iron. We call this an iron core. It could be a nail, it could be just a regular piece of metal, it doesn't matter. But it's got to be made of iron, all right? Or maybe nickel, but at least something magnetic. Iron works best here for us. So we're going to use an iron nail, and you got the multiple coils wrapped around here. And so what we're going to do is we're going to run electrons through the cord, around and around and around this metal iron nail. Okay, when it goes around this metal iron nail, and then it goes come out here and go back into the back end of the battery. So electrons come out one side of the battery, go around, and come in through the other. Now, the reason this is important is because as the electrons pass around here, the electrons start to influence the domains inside this iron nail. So right now they're demagnetized, which means they're pointing every which way. But as electrons start running around, those negative charges of the electrons influence the negative charges of the other electrons. The other electrons inside the iron nail. And remember, what we want is we want all those domains, let me bring this back, we want all those domains lined up. That makes it a magnet. So right now it's demagnetized, and we want it all lined up. So to do that, I'm going to run electricity through this wire. And as it goes through the wire, it goes around the iron nail, okay? And it will make all the domains in the iron nail line up. So to accomplish this, I need a source of electricity. So in this case, I'm going to be using a battery. All right. Now, kind of by hand, I'm going to hold it in. Okay. Now, this is an important thing you're going to need to know for our next segment. But really quickly, if you see here. All right. So right now, I've got them locked in, loaded. Okay. Batteries in here. And then when I touch it to the piece of metal, you'll notice nothing happens. Nothing happens because when you get something like this, okay, what you created is a circuit that the electrons travel around. And the problem is if that circuit is open anywhere, in other words, if it's not connected, the electrons can't travel. Electrons can only travel through what's called a closed circuit. That's how light switches work. The light switches work where you flip it on and then down for off. So when you flip it on, you're closing the circuit, allowing the electrons to pass. And when you flip it off, you open the circuit, preventing the electrons from passing through and stopping the lights from going on. So what we're going to do here is this. I want you to pay attention to this little section right here. Do you see this? This is my switch. When I touch it there, it closes the circuit. You see the metal touching the metal underneath? Okay? So if you'll notice here, when I flip this switch and then touch it here to this, oh, that's the wrong thing. It's too heavy for these weak batteries. But anyways, when I touch it here, you'll notice, picks it up. Open the circuit, drops. Close the circuit, magnetic. Open the circuit, drops. Okay? And it's all based off of, again, this whole idea of magnetized and then not magnetized. So right now it's not magnetized. Nothing's going on. The circuit's open. Close the circuit, electrons travel through and around and around and around, touch it down to here, and it's magnetized. Let go, open the circuit, still magnetized, because again, the longer you leave it, the more the domains are going to stay that way. But if I shake it a little bit, there we go, it falls off. And now you'll notice, circuit open, it's not magnetic anymore. You get a little residual domain. Like the domains are moving back and forth, so some of them might still be aligned if I leave this too long. That's how you can magnetize a piece of iron, is by forcing it to become magnetic, and then it just stays that way. But for right now, this is clearly still not magnetic until I close the circuit. That's the key, okay? So electromagnets work by closing the circuit, all right? The reason this is cool is because when we talked the other video about magnetic levitation, maglev trains, there's another kind of maglev train that uses the attractive force of electromagnets. And what they do is, to make something levitate, what they do is they attract it and release it really fast. Attract, release, attract, release, attract, release, until this thing, this object, literally starts to float in midair. And it's an attractive force using electromagnets, turning the switches on and off in succession really fast. You can literally just make it levitate and hover. So you don't have to just use the repulsive force to make something levitate. You can use the attractive force, as long as you flip it on and off really fast. Really cool video. I wish I had the chance to show you in class. Okay, so this is an electromagnet, and here's what you need to know. To make an electromagnet better, you want bigger batteries with more voltage, all right? You want a bigger iron nail. The thicker ones have more domains, therefore they become more magnetic. And then you want more coils, okay? So when it comes to electromagnets, the more coils, the better. The bigger the iron core, the better. And then the more voltage in the batteries, the better, okay? If you ever broken apart like an old clock on the wall, Maverick, close the door, please, thank you. So have you ever broken apart an old clock or an old piece of machinery, and you look inside, you might notice that inside there's a literal coil of, in fact, do I have one here? Oh well, nerds. Okay, can't find it. Sorry. But if I find it for the next video, I'll show you. So that's an electromagnet. Now, what do I want to show you next? Okay, so the basic idea here, just one more time, is the more coils, the better. The bigger the iron core, the better. And the bigger the batteries, the more voltage, the better. Okay? Those are the ins and outs there of an electromagnet. Now, what do I want to show you next? Okay. Let's talk about making objects turn on. So I'm going to find a little bit. Okay, so what you'll see here is I've got a battery. This is a lantern battery. It doesn't have the biggest voltage, but it's got a lot of stored energy, as you can see in there. It's rather large, okay? But anyways, I've got it connected to two alligator clips here, and these clips are connected to these two. Move all this extra stuff out the way. You all need to go and wait your turn. Okay. So over here you'll see I got the two paper clips. This is an easy setup yourself if you happen to have this stuff. I've got some enameled wire that I've rolled, okay, and I've looped the ends around each other. And if you could see here, I don't know how well this will focus, but okay. Well, anyways, I've actually shaved off some of the enameling here. Where's my camera? All right, can't see that very well. Okay, but anyways, shaved off some of the enameling so that you can see the copper wire underneath. So you got some red and then some copper being shown. So half copper, half enamel on these edge pieces. That's very important to conduct electricity because you got the electrons going in here. Anyways, what I got is I got electrons running through here. They go through a circuit, okay? From the negative side, all right, through here to the positive side and back. Now, this is not currently on because this connection is not united. Okay, so it's an open circuit right now. So electrons can't flow. Now, electrons can flow, however, when I close that circuit. So I'm going to use this piece of copper wire, which we have enameled, put it here. Now you'll notice it starts to flip a little bit there. And in fact, if I give it a little kickstart, it'll start to move on its own. And it's doing this because as electrons come out of here and down and through into this red the copper wire here, the electrons move through these loops. As they're going around the loops, because there are a lot of loops in there, right? They're exposed to the magnetic field of this magnet. And so what that magnet does is it influences these electrons up here, okay? Magnetic fields exist even if you can't see them. And it basically pushes the electrons. In fact, it pushes them away repeatedly over and over and over again, making the coil of wire feel that force because its electrons are being pushed away. So as the electrons move through, right, all those negative charges, anyways, all those negative charges are influenced by the magnetic field and they get pushed, and it basically flips this thing over and over and over and over again as the electrons move back through and then around to the positive end. So that's why batteries die, is because you've got a lot of stored negative electrons here. Lots of electrons mean a high amount, and we know things move from high to low. So all the electrons in the negative end want to move to the low positive end until everything balances out. And that's why your batteries stop working, because all the electrons have balanced out. They've moved to the other end until you have equal amounts of both sides. So that's what they're doing here. They're moving through. Now, if I open the circuit, it stops. All right, you still got a little sway there because of the because it's sitting on there. But anyways, electrons moving through makes the coil move. This is called a motor. So go to another room. Just go. Just go. You've already bent it and broken it. So go. It's unfortunate. Okay. Well, anyways, back to this. Where am I? Okay, so we have electrons going through this with a coil of wire. What am I talking about? A motor. Okay, so here's how a motor works. You might have seen these things right here. So this is a motor, and they're used in your toys, like if you ever have a remote control car or anything like that, or a fan, you've got like something like this in here, which is a motor. And basically, you've got a little thing inside here spinning, okay, and it spins this little thing right here, okay? So what you got inside here is you got a magnet and a coil of wire. And what you do is you run electricity through that coil of wire, right? And the magnet inside affects it, and as electrons run through, it spins the magnet, which spins this little thing, which turns your fan. That's kind of how motors work, okay? But here's what's cool. I can use electricity to create a motor. But as with all things, the reverse is also true. I can use a motor to create electricity. And so that's what I'm going to do next. Okay, so next up, what I got here is I've got a motor. All right, I got a piece of string. All right, you guys might remember this from before. I don't need you anymore. And then I've got a light bulb, okay? So what I need to do is I need to take this motor here. I need to spin this magnet, okay? So what I'm gonna do is I'm gonna spin the magnet inside. And when that magnet spins, it's going to affect the electrons in the coil of wire inside of this. So there's a coil of wire inside. As the magnet in between the coil spins, okay? It makes the electrons in the coil actually move, okay? And the electrons start to move. And when electrons move, you've created electricity. So by spinning the magnet inside, the magnet rotates. The magnetic field affects the electrons in the copper. The copper electrons move. They move through this long course all the way here to the light bulb and then all the way back, and they start to travel again and round, round, round. And that's what's going to make our little light bulb here turn on. Now, it's only going to turn on for a little bit, but it will definitely turn on. So let me flip this around. Bring it over here. Okay. So take your motor. Got my alligator clips connected to a light bulb. And I'm going to try to leave this somewhere you guys can see it. I don't know if I can prop this up some kind of way since my trusty science sidekick has decided to break my stuff and run away. I'll do this somehow. There we go. So you can hopefully see that little light bulb right there. So what I'm going to do, I'm going to take this coil of string and I'm going to loop it around this end repeatedly. Loop, 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 loop. Okay. So now what I got is this, if you can see. All right, I got it looped around the end of this motor, and what I'm going to do is I'm going to pull down. And when I pull, it's going to spin this little end piece, which will spin the magnet inside, affecting the electrons inside of the copper wire, and it's going to pull it back, come on, buddy. And it's going to turn this light bulb on, right? All right, here we go. 3, 2, 1. Erg. Try this one more time. That wasn't as bright as I would have liked because I don't think I pulled very well. Let's try this again. All right, move it around. Here we go. All right, 3. 3, 2, got in the black background. 3, 2, 1. Ow. This is so much easier in class. I kid you not. I think I even did this for you guys earlier this year, and it totally works like every time. And I have like no issues. But now I'm on camera, and I don't want to mess up, and I'm having a day. Here we go. 3, 2, 1. Did you see anything? Yeah. Let's try it again. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Or did I already bust this light bulb because I made such a bright light before? All right, 3, 2, 1. Oh no, the light bulb is not working. Are my circuits closed? Circuits closed. Light bulb, filament. Let's see filament anymore. I wonder if it's a light bulb. Let me try changing that up. All right, new light bulb, maybe new results. All right, light bulb connected, light bulb propped up where it can be seen. Can you guys definitely can't see that. You see this? Nope, nope, okay. All right, I think we can see that. So yeah, there we go. Okay, loop it around. All right, 3, 2, 1. There was a little flash. Why can't I pull? I'm trying to look at the camera and pull this at the same time. Just do your job, Ellis. Just pull. 1, 2, 3. There it was. I know that was a good one. Okay, so that's how that works. You take the coil of, you take the magnet, spin it really fast. It's around a coil of wire. The electrons in the coil of wire experience the magnetic field spinning, which makes the electrons move. And as electrons move through, they travel through the system, go through the light bulb, and moving electrons through a light bulb makes the light bulb turn on. There you go. That's how that works. So, yeah, those are 3 cool little labs. I usually let you guys do 2 of them, and then I do the 3rd one. But anyways, that's how that works. If you have some of the materials, it's worth the time and effort. If not, just watch and enjoy. And I'm sorry I can't do this with you live and in person.